Hello everyone. Today we shall look into fact table and dimension table differences. A fact table is a central table within a data model which stores the quantitative or numerical data. We understand that wherever we have large quantitative data or numerical data, it is said to be fact table. But the conceptual thing is it also contains the textual data which has dimensions, which are dimensions actually. Before going to discuss about dimension tables, let us understand this fact table very well. Okay, it is the fundamental component of star schema or snowflake schema, which are commonly used in data warehousing and business intelligence tools. Moving further, let us understand the structure. It typically consists of set of columns that represents the measures or quantitative data. The data like sales amounts, quantities, counts, duration, or any other measures in quantities specific to the business domain, it could be present, and this type of structure is present in fact table. Here we have foreign keys. In fact table, we have foreign keys which are related with the dimension tables. These foreign keys will link to the corresponding dimension tables. Those dimension tables may be the product dimension or store dimension or territory, date dimension or any other dimensions. Those dimensions are related by these foreign keys which are present in the fact table. Okay. Grain, the grain or level of details of the fact table, it refers to the level of which the measures are recorded. Till the finest level, the data could be captured in the fact table. Here, measures in fact table, they can be classified into three types. First one is additive measures. Additive measures are those which could be aggregated by simply summing them up, like sales amounts, quantities, or counts, or any other such data. Semi-additive measures, but they can be aggregated for some dimensions, but not for others. For example, balance measure in financial fact table, then they can be summed for particular time period, but they cannot make sense to sum across different time periods. Such type of measures which are included in fact table are called semi-additive measures. Non-additive measures, they are called as non-additive measures because they cannot be aggregated at all or have complex aggregation rules. For example, percentages, ratios, and other measures related to time calculations, they cannot be aggregated. Okay, let us move further. Here in fact table we have the aggregations. Few fact tables may contain pre-aggregated values or summary statistics where the values are provided to improve query performance. They are stored at higher level of granularity to support the data. Power BI supports defining aggregations to specify which summarized values to use for different levels of analysis. With respect to performance considerations, if the fact tables contains large data, they can really become huge volume of data. So few optimization techniques are used, like partitioning, indexing, and also aggregation part, or we could say summarizing, to ensure efficient query execution and response times. Okay, this is with respect to fact tables. Let us understand types of fact tables. Here we have transactional fact tables, which includes sales amounts, quantities, or timestamps. Second one is snapshot fact table, where we have the snapshot of inventory levels or account balances or stock prices. Third one is accumulating snapshot fact table, which consists of key milestones or events or the things which accumulate, like start dates or dates, durations, and progress indicators. The fourth one is periodic snapshot fact table, where the sales aggregated counts or averages over time period are represented. Factless fact table is the fifth one, where it contains only the foreign keys of dimension tables without any measures. You could seldom see this factless fact tables where it has only the foreign keys but not the other data with respect to dimension tables. Such tables are called factless fact tables. Derived fact tables are created by joining aggregating data from multiple fact tables or other sources. These are various types of fact tables which are understandable by using the real-time data. Moving on, we have understood about fact table. Let us understand about dimension table. Dimension tables are essential component of data model in Power BI. They provide descriptive information about the data stored in fact table, and they provide context for the measures which are stored in fact table. Okay, they provide descriptive information and they provide context for measures or data which is stored in fact table. Unlike fact tables, which contain numerical measures and other numerical data, dimension tables consist of textual data and categorical attributes which help analyze the and slice and dice the data. Attributes, here in dimensional tables, it consists of attributes that describe different aspects of data. These attributes provide context and allow for the segmentation, filtering, and grouping of data. For example, the data would be like product names, customer names, geographic locations, dates, categories, and various descriptive characteristics. Primary keys, each dimension table has a primary key column that uniquely identifies each row or record in the table. The primary key is used to establish relationships with the fact table, allowing for data integration and analysis across multiple dimensions. Moving further, dimension table consists of hierarchies which enable them to represent different levels of granularity. Okay, for example, a time dimension may have the hierarchy of year, quarter, month, and day attributes. Hierarchies enable drill down and roll up operations, which allowing users to navigate through different levels of detail in their analysis. Slow changing dimensions. These dimension tables account for changes in attribute values over time, and it is used to handle updates, inserts, and historical tracking of the dimension. Okay, different types of SCD, which is slow changing dimensions. There are three types, and they determine how changes in attributes are managed and stored in the dimension tables. Moving further, we have surrogate keys. These are the keys which are commonly used in dimension tables. They are artificially generated unique identifiers. We generate it maybe by using the index column or any unique column or making some uh, like specific code for particular products or any other dimensions. We make those surrogate keys. They are used instead of natural keys such as customer IDs or product codes. Instead of those codes, we make artificially generated, unique identifiers to maintain referential integrity. Okay, they are called as surrogate keys and they improve query performance. Denormalized or snowflake structures. Dimension tables can be structured in either denormalized or snowflake formats. In denormalized structures, all the attributes are stored in single dimension table, simplifying queries but potentially leading to redundant data. I would show you the normalization in another video. For now, we are understanding about dimension tables. The attributes are split into multiple related tables, reducing redundancy but requiring more complex joins. Moving further, we have descriptive attributes where dimension tables often include additional descriptive attributes that provide more information about the dimension. These are not used for analysis directly, but they provide additional context to descriptive details. For example, addresses, contact details, or descriptions about the product or any other store dimension or details about the nation. These are descriptive attributes which support and provide additional context within the dimension table. Let us understand about dimension table types. First one is confirmed dimensions. Confirmed dimensions are those dimensions which are shared and consistent across multiple fact tables. They provide a common reference for analysis, which ensures that the same dimension attributes and hierarchies are used consistently across different analytical contexts. They promote data integration, consistency, and accurate cross-functional analysis. These type of dimensions are called conformed dimensions. Role playing dimensions are dimensions which are used multiple times within the same fact table, each with different interpretation or perspective. For example, a date dimension can be used to represent order date, ship date, and delivery date within the same fact table. Role playing dimensions allow for different analysis perspectives without the need for separate dimension tables. I hope the date dimension is easily understandable, where we use the date dimension for separate dates, and we use DAX to activate the inactive relationships. Such role-playing dimensions are used in the dimensional tables. Moving further, we have read about the slowly changing dimensions, which capture the changes in attributes over time. Okay, junk dimensions. These are the dimensions that are created by combining multiple low cardinality attributes into single dimension table. Wherever there is low granularity, those tables are combined and they are made as junk dimensions. Okay, these attributes typically have discrete values or flags that are not individually significant for analysis. By combining them into junk dimension, it reduces the number of dimension tables and simplifies the data model. Moving further, we have hierarchical dimensions, as it helps us to understand these dimensions contain levels and relationships that enable drill down and roll up operations. As I have mentioned, it is like year, quarter, month, and day as hierarchy. Degenerate dimensions are the dimensions that are stored directly in the fact table instead of separate dimension table. Okay, these are the dimensions which are stored in the fact table instead of separate dimension table. They are called degenerate dimensions. These attributes do not have their own dimension table, but they are still used for analysis. For example, they include order numbers, invoice numbers, transaction IDs, and other IDs, which are useful in tracking specific events or transactions. We have virtual dimensions. They are the dimensions that are created on the fly during the analysis process, often through calculations or expressions or joins. We use DAX to make the on the fly virtual dimensions, which are not stored in the data physically, but they are stored virtually, and they are executed on the fly when we execute the DAX. Virtual dimensions are not physically stored in the data model, and they are derived dynamically based on requirements for analysis. This is all the information about fact table and dimension table. Hope you are able to understand. Thank you for watching, and we shall meet in the next video.